This lesson is a continuation to the first lesson about quadratic functions, so that's why it has a title of Quadratic Functions Part 2. And in this lesson, I'm going to dig deeper into the different quadratic functions, or actually the different quadratic forms, their associated graphs, and some facts about them. So the first form that you might be given in the exam is y equals a times x minus p times x minus q. And of course, a is not equal to 0, and p and q are real numbers. So the graph would look something like that. So the graph cuts the x-axis at two different points, which are p and q. So the first x coordinate is the value here, which is p, and the second x coordinate is the value q. And if I want to find x, which is the axis of symmetry, or the x coordinate of the turning point, and in this case it's a minimum point, it's the addition of p and q divided by 2. So it's basically p plus q divided by 2. So that's the axis of symmetry, which is also the x coordinate of the turning point. And if I want to find the y coordinate, I simply substitute the value of x here into the function y. So that's how we get the x coordinate and the y coordinate of the turning point. Now the second form is y equals a times x minus h, all of it squared, where h is a real number. And the graph of this quadratic form is basically something like that, where the axis of symmetry is equal to h. So depending on what number we have here, the axis of symmetry actually depends on h. And the x coordinate would be h, and the y coordinate is 0 because it cuts the y-axis at y equals 0. The third form is y equals a times x minus h, all of it squared, plus k. And in this case, the axis of symmetry is h, so it depends on the number here. And the y coordinate of the axis of symmetry is simply the number here, which is k. So that's how we get to define our axis of symmetry and our point, our turning point. And finally, the last form that you can get is y equals ax squared plus bx plus c. Now, to find the roots or the zeros, simply we need to equate the function to 0, and we can either use the formula, the quadratic formula, which is minus b plus minus the square root of b squared minus 4ac over 2a, or we can factorize to get the roots. But the idea here is that we need to equate the function ax squared plus bx plus c to 0 to find the roots. And to find the axis of symmetry, it's simply negative b over 2a, and b is the coefficient of x, a is the coefficient of x squared. So that's how we find the axis of symmetry, and that's how we find the x coordinate of the turning point. And in this case, it is a minimum point. However, to find the y coordinate of the minimum point, we simply substitute the x coordinate of the point into the function, and we will get the y coordinate. So that's how we find the roots, that's how we find the equation of the axis of symmetry, and that's how we find the coordinates of the minimum point. Last thing that I would like to talk about is simply the y-intercept. Now, to find the y-intercept, we simply substitute 0 into each x coordinate. So I will find the y value or the y-intercept by substituting x equals 0 into the equation, and that's how we get the y-intercept, which is the point where the graph cuts the y-axis.